Am I audible?
Yes, ma'am.
Fine. So any problem अभी तक जितना स्टडी करा है उसमें? अभी तक जितना स्टडी करा है the whole syllabus is going to come in midterm examination और वो मैंने Google Classroom पर भी शेयर कर दिया आपको सिलेबस भी. ओके, तो किसी को कोई भी प्रॉब्लम है तो पूछ सकते हो या फिर नेक्स्ट क्लास होगी वो हम एक डाउट सेशन ले लेते हैं थर्सडे. ओके, so today we are going to discuss multivariable optimization with constraints. In the last lecture, we have studied the multivariable optimization technique without constraints. Now, if the problems come with constraints, means some conditions are given over there. So now we have multivariable optimization with constraints. It means the constant may be equality or the inequality. It may be optimization with equality constants or inequality. Both problems will arise here with inequality constants. And so the general problem here is, in this case, अगर विदाउट कॉन्स्टेंट्स था तो हमारे पास सिर्फ ऑब्जेक्टिव फंक्शन गिवन था, कोई कंडीशन गिवन नहीं थी. अब हम कॉन्स्टेंट्स के साथ की बात कर रहे हैं, तो जो जनरल प्रॉब्लम होगी यहाँ पर, द जनरल प्रॉब्लम here is, it may be in the minimization form, it may be in the maximization form, but if the minimization form is given, then you have to convert that minimization into the maximization form, as we have discussed earlier. So suppose यहाँ पर मुझे minimization दे रखा है objective function, which is minimization of f of x, and this is subjected to, first I'm going to take equality constants here. So it's subjected to gj of x equals to 0, and this j varies from 1 to m, means we have m constants conditions here, and this x consists of x1, x2, total variables here are m, and this m is less than n. So is the screen visible to you? Is this screen visible to you? Yes or no?
No, ma'am.
The screen is not visible? Multivariable optimization?
No, ma'am.
Wait, I'm again sharing it. Is it visible now?
Yes, ma'am.
Fine.
Yes, ma'am.
Okay. So we have a general problem in which objective function that consists of total n variables and subjected to the set of constants which are equality constants, and we have m constants here and m is less than n. So the first thing is we have to convert this objective function which is in minimization form into the maximization. तो maximization में convert करने के लिए first क्या करते हैं, माइनस से मल्टीप्लाई कर देते हैं. सो इट विल बी लाइक maximize of z is minimization of minus it. And we have m is less than n. This must be hold. Otherwise, the problem will be overdefined, and in general, the solution will not be obtained if this condition does not hold. So it must be less than n. And if the problem is of this type, then we have several techniques to solve these type of problems, in which the first one is the direct substitution. Direct substitution. Second method is constant variation technique. Constant variation technique. And third method is method of Lagrange's multipliers. Lagrange's multipliers method. So first I'm going to take direct substitution technique. As the name indicates, direct substitution में क्या होगा? We have an objective function subjected to the set of constants. So we generally take, suppose we have m variables, m constants and n variables. So we choose any m variables out of n and express them in terms of n minus 1 variables. n minus m वेरिएबल्स की टर्म में हम उसको एक्सप्रेस कर देंगे. तो क्या होगा, ये जो हमारी प्रॉब्लम होगी, दैट प्रॉब्लम कंसिस्ट ऑफ एन सिंगल प्रॉब्लम, जो पहले हमने विदाउट कांस्टेंट्स वाली प्रॉब्लम पढ़ी थी. तो उसी टेक्निक से ये प्रॉब्लम सॉल्व हो जाएगी. मींस विद द हेल्प ऑफ इनइक्वालिटी हम उसको सिंगल एक प्रॉब्लम में ट्रांसफॉर्म कर देंगे. एंड दिस मेथड हैज अ डिसएडवांटेज दैट it appears to be simple, but it's not as simple. अगर हमारे पास number of variables ज़्यादा होते हैं तो ये problem इस method से solve करना typical हो जाता है. So this is in case for if we have less number of variables here. So I'm going to take a problem which we are going to solve using the direct substitution technique here. The question is, find the values of, this is the problem from multivariable optimization with constants. और direct substitution से हम इसको solve कर रहे हैं. So find the values of x, y and z that maximize the function f of x, y, z is equals to 6xyz by x plus 2y plus 2z, where x, y and z are restricted by the relation condition है यहाँ पर x by z is equals to 16. So we have an objective function जिसको मुझे मैक्सिमाइज करना है, वैल्यूज फाइंड आउट करनी है XYZ की, and the condition equality constant here is XYZ is equals to 16. So what we have to do, मैं यहाँ से इसको सब्सटीट्यूट कर दूंगी वैल्यू फाइंड आउट करके. आई एम टेकिंग x is equals to 16 by yz and substituting that value in my objective function. Now the function consists of two variables here, and solve the method, the previous technique which we have solved using classification, positive definite and the negative definite. Find out the Hessian matrix and check कि किस condition पर वो positive आ रही है, कहाँ पर वो negative आ रही है. The same method. So look at the solution. Here we have x, y, z is equals to 16. So the value of x is 16 by yz. This implies my function, given function, which is in three variables, x, y, and z, it will be equal to this is 16 by yz multiplication with yz divided by 16 by y, 16 by yz plus 2y plus 2z. So it's cancelled out, and it's equal to, this is इसको सॉल्व करने के बाद दिया जाएगा 48 yz by 8 plus y square z plus yz square. And now our objective function in terms of two variables, yz. So the problem is now converted into f of yz is 48 yz divided by 8 plus y square z plus yz square. अब हमें इस फंक्शन को देखना है कि ये कहाँ पर मैक्सिमाइज हो रहा है, कहाँ पर मिनिमाइज हो रहा है. So again the method is, first we have to find out the stationary points, and for obtaining the stationary points क्या करना होगा, फर्स्ट स्टेप में हमको with respect to these variables find out its partial derivatives with respect to y and with respect to z and equate them equal to 0. तो जब हम ये partial derivative equated to 0 करेंगे, we will get a stationary point, and that stationary point we have to check if the sufficient the conditions की Hessian matrix which is the matrix for the second order derivatives, कि वो values कहाँ पर negative definite पे, कहाँ पे positive definite पे. Is this okay to you? Is this clear? This is the same problem which we have discussed in the last lecture. Now, सिर्फ जो भी relation दिया गया है उसमें से हमें substitute करना है. That's why this is the method for substitution in case for the equality constants. Is this okay to you? My voice is audible?
Yes, ma'am.
Okay, fine. So two variables हैं यहाँ पे y and z. तो सबसे पहले मैं evaluate कर रही हूँ del f by del y, then del f by del z. This is the necessary condition for obtaining the stationary points. With respect to y हम इसको partially derivate कर रहे हैं. So treating the other variable as constant, and we will get here 48z. I'm writing down directly, just check it yourself. इसको evaluate करके आएगा 8 plus y square plus yz square minus plus z square divided by h plus y square z yz square whole square. This is obtained when we differentiate partially with respect to y. And after evaluating this, the compact form is 48z h minus y square z divided by h plus y square z plus yz square whole square. In the same way, when we differentiate partially with respect to z, we have obtained 48y 8 minus zy square divided by 8 plus y square z plus yz square whole square. Now I'm equating to 0 these two partial derivatives. So when we equate it to 0, del f by del y equals to 0 and del f by del z equals to 0, we have, it gives the value of y is equals to z and this value will be equals to 2. So for a stationary point, we denote it by s star. We will get the value of both these two will be 2. And when we get 2, so from substituting these two values, x star की जो वैल्यू आएगी, because x y z हमारे पास कितना दे रखा है 16 and these two are 2, so the value of x star is, therefore x star will be 4. So stationary point is means x star, y star, z star. It's equals to 4, 2, 2. Now at these values, we will check whether we get maximum or the minimum. उसके लिए we know that the sufficient condition होती है जिसमें हम Hisen matrix evaluate करेंगे and Hisen matrix evaluate करने के बाद जितने भी उसमें उसके determinants evaluate होंगे, if all of them are positive, then positive definite. If all alternate positive and negative, then negative definite. So it depends on the conditions. Now, sufficient conditions. I have also uploaded all the lectures in the YouTube. You can check from there. So second derivative यहाँ पर total मेरे पास होंगे. We have 4 second derivatives. Del 2f by del y2, del 2f by del z2, del 2f by del y del z, and del 2f by del z del y. ये सारों second order derivatives मेरे को यहाँ पर evaluate करने हैं at the points. These are the points here. So del 2f by del y2 second order derivative, इसको एक बार और partially differentiate कर रहा है with respect to y and we have obtained, ये value यहाँ obtained होकर आएगी minus 2yz by 8 plus y square z whole square minus twice of 8 minus y square z. This is 2yz plus z square. Please check it yourself. इसको evaluate करके यही आ रहा है क्या? यही आएगा even though. This is whole cube. So this is the second order partial derivative with respect to y. Now this is in terms of y and z. And the value of y and z is at This is y z means 2 and 2. इसकी जगह भी 2 substitute करना है and z की जगह भी 2 substitute करना है. So we have obtained the value is minus 4/3 here. In the same way, evaluate the second order partial derivative with respect to z. So similarly, del 2f by del z2 is equals to, ये सेम ही आएगा इस पर भी, at y star and z star. We have getting the same value here because y की वैल्यू भी 2 है, z की वैल्यू भी 2 है. तो इसी तरीके की फॉर्म बनेगी and it's minus 4/3. Now the next second order partial derivative is del 2f by del y del z. So it's del 2f by del y del z. It's equals to 48 8 minus 2 y square z by 8 plus y square z plus yz square whole square minus 2z 8 minus y square z. This is y square plus 2yz divided by yz square whole cube. And this is the same value for del 2f by del z del y. दोनों की यही वैल्यू आएगी. Now at stationary points, these derivatives will be means at y star and z star 2 and 2 पर इसकी जो वैल्यू आएगी it's minus 2/3. So we have these partial derivatives minus 4/3, minus 4/3 and minus 2/3, minus 2/3. These are the values for writing the Hessian matrix. Now Hessian matrix which is denoted by J. HESS Hessian matrix J at y star z star, it's equals to, this is minus 4/3, minus 2/3 and minus 2/3, minus 4/3. Now we have obtained the determinants from this Hessian matrix. So J1 is equals to determinant of minus 4/3 and its value is minus 4/3 negative, and J2 is equals to the determinant of this 2 cross 2 matrix. This is minus 2/3. Minus 4/3. इसकी वैल्यू पॉजिटिव आएगी नेगेटिव आएगी? This is 16/9 minus 4/9, 12/9 or 4/3. So you see that J1 is negative and this is positive, right? So which type of matrix is this? Hessian matrix कैसी है यहाँ पर हमारी? Is it positive definite or the negative definite? बताओ, पॉजिटिव डेफिनेट है नेगेटिव डेफिनेट है? पढ़ी थी ना लास्ट लेक्चर में कंडीशंस. Am I audible to you? Am I audible to you? Akshay, Akshita, Anisha.
Yes, ma'am.
Not getting any response. पता ही नहीं
Yes,
चल रहा
ma'am.
what बात ये कर रही है. मैं पूछ रही हूँ कि ये पॉजिटिव डेफिनेट है और द नेगेटिव डेफिनेट. लास्ट लेक्चर
Ma'am,
में
indefinite.
नेगेटिव और पॉजिटिव.
Indefinite, ma'am.
Your voice is not clear. This is the negative definite because यहाँ पे जो first जो हमारा J1 evaluate हुआ है it's negative and next one is positive. अगर ये सारे positive आते तो positive definite होती because first is negative and the second is positive. ये जो हमने sufficient conditions पहले पढ़ी थी. If you remember the conditions here. ये वाली. It's not opening this time. तो हम यहाँ पर मैट्रिक्स इवैल्यूएट करते हैं. This is the condition. Sufficient condition obtain the Hessian matrix for second order partial derivatives. It's positive definite when x star is a relative minimum point and it's negative definite so it has a relative maximum point. तो यहाँ पर हमारी ये जो आ गई है negative definite. So the corresponding points are the maximum points. You can write Hessian matrices is negative definite. Hence, x star, y star, z star. This is our stationary point जिसको हमने evaluate करा है, which is 422. Corresponds to the maximum of function x, y, z. So this is the technique for evaluating by substitution. Next, we will study the method for constant variation and Lagrange's multipliers method in multivariable optimization technique. Is this clear to you?
Yes, ma'am.
Okay, I'm going to write down one more problem and you just try to solve the problem by yourself. इसी टेक्निक पर बेस्ड मैं एक और प्रॉब्लम यहाँ पर लिख रही हूँ. जितना लास्ट क्लास तक हमने करा है दैट विल कम इन योर एग्जामिनेशन. और सेपरेटली सिलेबस भी मैंने गूगल क्लासरूम पर शेयर कर दिया है. तो प्रॉब्लम इज find the dimensions of a box. Find the dimensions of a box of largest volume that can be inscribed in a sphere of unit radius. Find the dimensions of a box of largest volume that can be inscribed in a sphere of unit radius. So this is the problem which you have to try to observe. So suppose मैं आपको इसकी फॉर्मुलेशन बता देती हूँ क्या होगी. सपोज मैं कंसिडर कर रही हूँ जो डायमेंशन है बॉक्स के x2x 2y and 2z. इट मीन्स जो फंक्शन मेरे पास है विच इज नथिंग बट द वॉल्यूम. वॉल्यूम कितना होगा 8xyz. ठीक है. लेंथ विड्थ एंड इसकी मल्टीप्लाई विद कंडीशंस हियर. जो यहाँ पर स्फीयर है स्फीयर ऑफ द यूनिट रेडियस. हमें उस बॉक्स का डायमेंशन निकालना है. फाइंड द डायमेंशन ऑफ द बॉक्स दैट कंसिस्ट ऑफ दैट इंस्क्राइब्ड इन ए स्फीयर ऑफ यूनिट रेडियस. तो कंडीशन यूनिट रेडियस की जो इक्वेशन होगी दैट विल बी 1. So you just try it yourself. So this is again the problem जिसे मुझे conditions find out करनी है. That is given with the equality constant. तो इसी मेथड से ये प्रॉब्लम सॉल्व हो सकती है. ठीक है. यहाँ पर आप क्या करोगे एक वेरिएबल z की वैल्यू निकाल ली. z is equals to 1 minus x square minus z square and substitute it in the given function here. Now again we have a function that consists of two variables here. Find out its partial derivatives. The same process are adapted in the previous one. Find out partial derivative, equate them to 0, find out the stationary points, then find the Hessian matrix and check is it positive definite or the negative definite. So you just try it yourself. Now any problem? Please let me know. And write down the attendance present in the chat box. So any problem with इसके साथ कोई इसी में कोई कुछ किसी को क्लियर नहीं हुआ है कोई प्रॉब्लम? This session is going to end in the next 2-3 minutes. Please let me know if you are facing any issue. Shivam, Arpit, Komal. Yes, any problem? Is this clear? Yes or no?
Yes, ma'am.
Okay, fine. So do revise all the things, all the syllabus जो अभी तक cover हुआ है, and in Thursday we will discuss the problems. आपकी जो भी problems हैं, ठीक है, तो वो हम Thursday में discuss करते हैं. Fine.
Yes, ma'am.
Okay.